Right, yesterday in class we talked about opposite vertex and the base and height of a triangle, and then we talked about triangles in general, being able to calculate the area of them. So the opposite vertex is just the point opposite of the chosen base. So that means if you're looking at this triangle here, notice that they've labeled the base as this side or edge, and then the opposite vertex would be this point that's directly opposite of that. That would be called the opposite vertex. Here, if you're looking at this triangle, they labeled this as the base. The opposite vertex would be there, OV. And then if you're looking at this base, right, the opposite vertex would be this point here. That would be our OV. So that is opposite vertex. The base of a triangle is any side of a triangle. So you can choose any side of the triangle to be the base of the actual triangle. And the height of the triangle, so the height must be perpendicular to the chosen base. Perpendicular means it must make a right angle and it must intersect with the base chosen. So going back to this example here, notice that this is the base. Your height is going to be this dotted line here, this dotted line here, or this dotted line here. That's called a dash segment. But any of those dash segments can be can have the height because they all intersect with the base. In this example here, the base is chosen here. The height is going to be represented by this dash segment that goes up to the opposite vertex, and it makes a right angle, right? Because it still intersects with the base. And over here, this dotted line segment also represents the height. Notice that this right here, you can draw a line and draw down to make that right angle if you need to, but all those represent the heights. The height must correspond with the base. So the second thing that we talked about is that these represent the heights of a triangle, and these do not. So these are examples, these are non-examples. And I told students that they needed to tell me what's true about these statements. So any side of a triangle can be a base. That is true. There's only one possible height. Well, looking at this example here, I could represent height in multiple different ways. And if I choose, right, if I'm looking at this triangle, it's the same triangle flipped around. So notice that the height can be different, right? It can be different because the sides, the base chosen, and the height can be different in a triangle. It doesn't have to be the same, so this is not true, it's false. The height is always one of the sides of the triangle, so that's not true. Notice in our examples, it is not the height. It's not one of the sides. A height that corresponds to a base must be drawn at an acute angle. This is not an acute angle. This is a 90-degree angle, so that's also false. Over here, a height that corresponds to a base must be drawn at a right angle. That is true. This is a right angle here, so we need to make sure that we can apply that. Once we choose a base, there's only one segment that represents the corresponding height. Here's a base chosen. I can represent the height in 3 different ways, so that's false. And a segment representing the height must go through a vertex. This height doesn't go through a vertex. This height doesn't go through a vertex. This height doesn't go through a vertex. So that's false. Right, then we flipped over the page and it says for each triangle, we need to label a side that can be used as a base and a segment showing its corresponding height. Record the measurements for the base and height in the table and then find the area of the triangle. In the last row, you're going to write an expression for the area of the triangle using B and H. So I'm just going to go ahead and we'll look at these problems. I'm going to choose this as my base, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for A, the base is 10. The height must intersect, so I'm going to use this dotted dash segment here. 1, 2, 3, 4, 5, 6, 7. The height is 7. I know that 10 times 7 is 70, but remember it's a triangle, so we must divide by 2 because 2 identical triangles make a parallelogram. 70 divided by 2 is 35 square units. For B, I'm going to choose the base to be 1, 2, 3, 4, 5, 6. Base is 6. And the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that I'm using straight edges in order to find these numbers. I'm not using, this is called the hypotenuse, but I'm not using that because that's much more difficult to find than just using straight edges. So 6 times 11 is 66. Remember, it's a triangle, so I have to cut it in half because two identical triangles make a parallelogram. 66 divided by 2 is 33. All right, in C, the base of this triangle is here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that I did not extend this outward because I'm only focused on measuring the actual line segment from point A to point B, or from A to B, either way. So that's 10 is the base. The height is going to be this dash segment here, which would intersect with the base if I brought it out. It's 1, 2, 3. I know that 10 times 3 is 30. Cut that in half. You get 15 square units. And then D, the base of this is 1, 2, 3, 4. The height of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There is missing a little line there, so this is 4 times 11, which is 44, divided by 2 equals our 22 square units. Now it tells us to write an expression, so remember we're multiplying base times height and we're always dividing by 2. That's going to give us the area of our triangle. Okay? And the last thing that we did is, this is basically, now we're off the grid. So this was kind of on the grid, and now we're moving away from that. So we need to find the area of these triangles. My formula is base times height divided by 2. So this one, the base is 5, the height is 6, so that is 30 over 2, which equals 15 centimeters squared. For B over here, it's 4 times 4 divided by 2. That's 16 divided by 2. That equals 8 centimeters squared. For C over here, notice that you have some wonky numbers. You cannot use this 3.5 as, if you use this as a base, right? The height some people wanted to use 7, and 7s can't be used because that angle there is off. So we actually have to use a different number. So for this one, I'm going to use 7 and 3 because they do make that right angle up there. That equals 21 divided by 2. That equals 21 divided by 2, right? We've got to set that up because some of us are 2 goes into 2 one time. 2 cannot go into 1, so I put a 0. 2 goes into 10 5 times. So 10.5 centimeters squared. Down here in problem D, I'm going to use 8 and 3.5. 8 times 3.5. This problem can be done one of two ways. Some students use the distributive property, which is taking 8 and multiplying it by 3 first. 8 times 3 equals 24. And then they took 8 and they multiplied it by half. So when I think about this problem, I'm really saying, what is half of 8? And if I say, what is half of 8? That is 4. And then I would add these two things together, which gives me 28. And then I'd have to cut that in half, which is 14 centimeters squared. Another way to do this problem is just to do 3 and 5/10 times 8, right? Notice that you have a tenth here, so that means that's the only thing that you have, so you better have a tenth in your answer. 8 times 5 is 40. 8 times 3 is 24. And then plus 4 is 28. Because there's a tenth, I need to move this one time to the left. So it should be 28, just like that. And then our last problem over here, I'm going to use 6 and I'm going to use 5. 6 times 5 divided by 2, that's 30 divided by 2, which equals 15 centimeters squared. So that was from today's lesson. So really it's being able to find the area, computing it on the grid and off the grid, and understanding the true-false statements about triangles.